Just make a little video of the problem that you sent me with a screenshot today and just kind of walk you through this. This one requires some constructions in steps 2 and 3, and these are actually constructions that it's in your construction packet. So maybe when you get to do these yourself, you'll kind of understand these steps. But I'll walk you through the proof here. So AB is parallel to CD, so that's given. Okay, so we've got this top line and CD is parallel. And then it says, number 2, construct BE perpendicular to CD such that point E is on CD. Okay, so we're going to construct BE to some point E so that it's perpendicular. So I'm going to just draw this, and you can construct this with a compass and a straight edge, so there's nothing that's, you know, that you can't do this anytime that you're doing a proof, okay? And this one just kind of leads us in this direction. So there is the constructed line, and now this is perpendicular, so this is a right angle, and we're going to call this point E. Okay, so we're just adding to the figure, but we're not changing anything else about what's already given. And then step 3, we're going to do something similar, construct CF perpendicular to AB. So we want a perpendicular line from point C to the line AB. So I'll make that a different color. And it's going to, we're going to just call that point F. Okay, just according to the directions in step 3. And that is perpendicular, so it's a right angle. Okay, then let's walk through the rest of the proof. So that's just what it said to do in steps 2 and 3, and that's where the points that it's talking about is coming from. They're coming from constructed lines. So we can always construct a line perpendicular to any other given line. Okay, so then it says angle, the measure of angle CFB. So CFB is a right angle, it's 90 degrees, and also angle BEC is a right angle because it's perpendicular. Okay, so that's given right there. And then so CF, so here's CF is congruent to what? And the reason is any point on one parallel line is the same distance from the other line on a perpendicular transversal. So the shortest distance between two parallel lines is a perpendicular line, and both of these are perpendicular, so they have to be the same distance. So CF is congruent to BE, and that would be the choice in the drop down would be BE. Okay, now we've got, what else do we have? BC equals BC. Well, that's the sort of the hypotenuse of both of these triangles. All right, and now we have a congruence between BCF, and CBE. So here's CBE. So these two triangles are congruent, and this is the hypotenuse leg criteria. It's not one we don't use very often, but if we have a right triangle, two right triangles, where the hypotenuse is congruent and also one leg of the triangle is congruent, then we can also say that the entire triangles are congruent. All the corresponding sides are congruent. So once we've proven that, we go to our conclusion, which is what we're trying to prove, is that alternate interior angles are congruent. Well, here's alternate interior angles, and they're corresponding angles of congruent triangles. So that's where step 7 comes from. Okay, if you still have some questions about this, we can go over it in class tomorrow. Bye.